This is my trigonometry course. Today we're going to learn a different unit for the measure of angles. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In previous classes, we learned the degree unit for the measure of an angle. And most likely degrees came from the number of days in a year. The number of days it takes for the Earth to orbit around the Sun. And there's not exactly 360 days, but roughly there are 360 days. And that's where the degree unit most likely came from. But when you go into upper mathematics, we're going to use a different unit for the measure of an angle called radians. And radians are going to be more practical when you take your calculus courses. And they're also used for various applications. The good news is those are the only two units you're going to use really for the measure of angles: degrees and radians. Now, if you have a circle with a radius of 1 and a central angle theta, then radians are defined to be the length of the corresponding arc. So this angle measure would be defined to be whatever this arc length is. And so when you define radians, you always use a circle with a radius 1. And again, there are many reasons that we define radians this way. You're going to learn an application maybe in the next class or the class after, and in calculus, like I said, you're going to see why we prefer these units. Now, because the circumference of a circle is 2 pi r, remember, if you want to find the circumference of a circle, the distance all the way around the outside of the circle, the perimeter that is, if you want to find the perimeter or the circumference of a circle, you use this formula 2 pi r. We learned that in previous courses. And the circumference of this circle that has a radius of 1 would be simply 2 pi, because r is 1. So the circumference of this circle here is simply 2 pi. And because r is always defined to be 1 when you're working with radian measure, that means that 2 pi radians is equivalent to 360 degrees. 2 pi radians is one complete rotation. That's the measure of one complete rotation in radian units. Now, if you divide both sides of this equation by 2, then you get a simpler relation. We see that pi is equal to 180 degrees. Now, notice that we don't say pi radians is equal to 180 degrees. We just say pi is equal to 180 degrees. You're not really required to write the unit for radians. When you write a number in degree units, you do have to write the degree symbol. As you can see there in purple, we have 180 with our little degree symbol at the upper right. But when you write pi radians, you don't have to write out the word radians. And there are reasons for that, but we'll talk about that later on in the curriculum. But you're not required to write any kind of symbol or abbreviation for radians. Now, you could write the abbreviation. You could say rad, R-A-D, that's technically the abbreviation. But you're not required to do that. So when you see that pi is equal to 180 degrees, that means that pi radians is equal to 180 degrees, but you don't have to write radians. And if you divide both sides of this purple equation by 2, then you see that pi over 2 is 90 degrees. And if you divide both sides of the purple equation by 4, you see that pi over 4 is 45 degrees, and this just gives you an idea of the most common angle measures that you're going to see in radian units. But let's come up with a universal method for converting between radians and degrees. So we're going to use something called the factor label method. You're going to use this in chemistry courses and physics courses, and we used it in my arithmetic course. And the factor label method is simply used for converting between different units. It's a method that helps us to keep track of the different units and make sure that we're converting properly. So first we're going to convert from degrees to radians. So we're going to be given a number in degrees, some degree measure, and you're going to multiply by this this factor, pi over 180. Pi over 180 is the simplest factor conversion that we could use. We could use 2 pi over 360, or we could use pi over 4 and 45 degrees. We could use any relation we want. We would get the same answer, but pi is equal to 180 degrees. That's the simplest conversion factor that we're going to use. So this is considered to be a factor conversion. And notice that we're labeling everything. We're labeling with degrees and radians. That's why it's called the factor label method. The factor label method. Now, because degrees over here are on top, you can consider this to be degree measure over 1. The degrees are on top over here, and over here they're on the bottom of the fraction. That means they cancel out. So the yellow degrees go away, and you're left with these red radian units. So if you want to convert from degrees to radians, you simply multiply your degree measure by pi over 180. It's that simple. On the other hand, if you want to convert from radians to degrees, you multiply your radian measure by 180 over pi. So you just flip the conversion factor. It's the same conversion factor, you just flip it. So this is very easy. So let's do an example where we convert from degree measure to radian measure. We have 36 degrees, and we're going to multiply by pi over 180 degrees. There's pi radians and 180 degrees. Now notice that I didn't write radians here. This is where things get a little confusing. You're not required to write radian units. And there are various reasons for that. We can go into that in future classes, but you're not really required to write radians. You can write them if you want. If you want to write the units, you would write rad as an abbreviation, but you don't have to write them. You're not required to write rad every time you write a radian measure. But you are required to write degree, the degree symbol. And so you don't have to spell it out like you see here. Obviously that would be kind of tedious. So we just write the degree symbol. And notice that the degrees cancel out. Those units cancel out. And so we multiply 36 by pi over 180. And you can consider this 36 to be 36 over 1 if that helps. And remember, you multiply the denominators and the numerators when you're multiplying fractions. So we get that. And if you reduce the fraction, you get pi over 5. So remember, when you write a number right next to pi, or any symbol, that means you're multiplying. 36 right next to a symbol means you're multiplying 36 by that symbol. So 36 degrees is pi over 5 radians. But again, we do not write radians over here. You don't have to do that. You can do that. It's not wrong to write rad for radians, but you're just not required to do that. And again, we'll talk about that more maybe in a future class, why exactly that is. So now let's try converting in the opposite direction. When we were converting from degrees to radian measure, we multiplied by pi over 180. And now when we convert from radians to degrees, we're going to multiply by 180 over pi. We're just flipping the conversion factor. So let's do a practice problem. Now we have 2 pi over 3 radians. Now, it doesn't say rad, it doesn't say radians, so how do I know that this is in radians? Well, remember, there's only 2 units that we use for the measure of an angle, radians or degrees. If you see a degree symbol here, then you know you're in degree units. If you do not see a degree symbol, then you know you're in radians. So that's how you tell. There's only 2 units that we use for the measure of an angle. And another giveaway is if you see the pi symbol, then most likely you're in radians. Now, you don't have to use the pi symbol if you're going to write a radian measure, but 99% of the time, if you're in radian units, you're going to see the pi symbol. So now let's multiply by 180 over pi. We just flipped the conversion factor, so now degrees are on top. And the radians are not going to cancel out because, again, there are no radian units that we have to really write, but I guess you could technically consider those to cancel out. So 2 pi times 180 is 360 pi, and 3 times pi is 3 pi. Notice that the pi symbols are going to cancel out, they disappear, and 360 divided by 3 is 120. Now we have degrees, the degree symbol, and it doesn't cancel out, so that's our final answer there. Degrees. So let's do some practice problems. We have the measure of various angles in degree units, and we're going to convert to radian units. So I'm going to take that angle measure and multiply by pi over 180 degrees. And I get 80 pi over 180. And notice that the degree units cancel out. And I can reduce that to 4 pi over 9. So it's that simple. Again, you don't have to write radians. So now let's convert 150 degrees to radian units. So we get 150 pi over 180. And it looks like that's going to be 5 pi over 6. Okay, now let's convert 315 degrees to radian units. The degree symbols cancel out, and we're left with 315 pi over 180. And if we reduce, we get 7 pi over 4. So now we have 1 degree. We're going to convert that to radian units. And we just have pi over 180 radians. The degree symbols cancel out. And there you go. So 1 degree is pi over 180 radians. So I want you to try number 5. Again, pi over 180 is your conversion factor. So start by rewriting 700 here, and then multiply by your conversion factor, pi over 180, and when you come back, we'll do it together. All right, we're back. So we get 700 pi over 180. The degrees cancel out. And that's going to be 35 pi over 9, I believe. So if you got that right, excellent. So go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. So we're going to rewrite 157 degrees and multiply by the conversion factor. And we get 57 pi over 180. If we divide both sides of the fraction by 3, we get 19 pi over 60. So if you got that right, perfect. If you had a little trouble reducing that, that's okay. Okay, number 7. Go ahead and try number 7. When you come back, we'll do it together. All right, we're back. So I'm going to rewrite the degree measure and multiply by the conversion factor. And we get 10 pi over 180, which reduces to pi over 18 radians. And again, you don't have to write radians. So if you got that right, good. Try number 8, and when you come back, we'll do it together. Okay, we're back. The degree symbols cancel out, and we get 275 pi over 180. And don't be afraid to use your calculator. We can divide 275 by 5, and we get 55. You can do this in steps if you want, that's okay. 180 divided by 5 is 36. And that's all we can do. That's reduced. So if you got that right, perfect. Again, if you had a little trouble reducing, that's okay. So now we're going to go in the opposite direction. We're going to convert from radians to degree units. Again, notice that we don't write radians, we just write pi over 12. If there's no degree symbol, then that means we're in radians. So now, instead of multiplying by pi over 180, we're going to multiply by 180 over pi. We're flipping the conversion factor. So we get 180 pi times 12 pi, and notice the pi's cancel out. In most cases, the pi's are going to cancel out. And 180 divided by 12, you can use your calculator for that if you want to. That's going to be 15 degrees, and technically we should write degrees because the degrees really don't cancel out in any of these intermediate steps. And of course we want degrees in the final answer. That's the whole point of the problem. So as you can see, this is really not that difficult. Okay, let's try number 10. 3 pi over 4 radians. If we convert that to degrees, we get 540 pi over 4 pi. The pi's cancel out, and 540 divided by 4 is 135 degrees. And again, you want to write your degree symbol on each one of these steps because the degree symbol doesn't go away. Okay, let's try a couple more of these before you try one on your own. So 180 times 7. Don't be afraid to use your calculator. We have 1260 pi over 6 pi. Obviously the pi's cancel out, and 1260 divided by 6 is 210. So there you go. And now we have radian measures, but there's no pi. We don't see a pi here. I just want you to be aware that you don't necessarily need a pi factor, but we are going to have to round, because when we multiply by pi over 180, the pi is not going to cancel out. So let's take that radian measure and multiply by 180 over pi. We're going to convert to degrees, and this is where we really need our calculator. 8 times 180 is 1440 degrees, and we could leave our answer in this form, but when you write an angle measure in degree units, you really don't want to leave it like this, because that doesn't really tell us much. So we're going to take 1440 and divide it by pi. Now if you're using a graphing calculator, you want to push the divided by button, and then the blue button, the second blue button. It's the blue button that says second. And then you want to push the pi button. It's the upside down V at the right, the middle right, and it has a little blue pi button on it. It's right below the number, the button that says clear. It's right below that. It has a pi. Push that button and then press enter. And we get approximately 458 point, and it says round to the nearest thousandth, so 0.366 degrees. Now if you're using an iPhone, you want to rotate your phone and enter 1440 obviously, and then divided by, and then you're going to push the pi button right in the bottom middle of the screen, and then press equals, and you should get the same number. Okay, so let's try another one of these. 2.64. We'll try one more before you try one on your own. And we can do this really quickly if we want. 180 times 2.64, enter, and then divided by the pi button, enter. And we get approximately 151.261 degrees. So there you go. As you can see, converting back and forth between radians and degrees really is not that difficult. You just have to remember your conversion factor and when to flip it, so you can convert from degrees to radians or radians to degrees. So I want you to try number 14, and when you come back we'll do it together. Okay, we're back. So pi over 10 radians, if we convert that to degrees, we're going to get 180 pi degrees over 10 pi. The pi's obviously cancel out. And we have 18 degrees. So if you got that one right, excellent. Okay, go ahead and try number 15. And when you come back, we'll do it together. All right, we're back. So we get 900 pi degrees over 4 pi. The pi's cancel out. We're left with 900 degrees over 4. And then we get 225 degrees. 900 divided by 4 is 225. So if you got that one right, excellent. Okay, go ahead and try number 16. And when you come back, we'll do it together. All right, we're back. So 7 pi over 3 radians converted to degrees is going to be 180 times 7 is 1260 pi degrees over 3 pi. The pi's obviously cancel out, and 1260 divided by 3 is 420. So we have 420 degrees. So if you got that right, perfect. Now try a problem where we don't have a pi symbol. And I want you to use your calculator and round to the nearest thousandth. So you're going to write your number, and then just as in the previous problems, you're going to multiply by 180 over pi. Try that problem. When you come back, we'll do it together. All right, we're back. So 6 times 180 is 1080 divided by pi. Enter. And so we get 343.775 degrees. So if you got that right, excellent. Okay, so we learned how to convert between radians and degrees, and we learned what radians are. We learned how to define them. So now we're going to use radians with trigonometry, which means that we're going to plug in our radian measures into trigonometric functions. So we need to find sine pi over 3 without a calculator. So these are problems where we can determine the answers without calculators. So what that means is that this is a special angle. So just to get some practice with unit conversions, let's go ahead and do the unit conversion down here. So we're going to convert to degrees. And remember, when you're converting 2 degrees, the 180 is going to be on the top. The degree symbol is going to be on the top. So we get 180 pi degrees over 3 pi. And if we simplify that, we get 60 degrees. So what this means is that sine pi over 3 is actually the same thing as sine 60 degrees. So now we can determine what this is. It's very difficult to figure out what sine pi over 3 is because we just don't recognize pi over 3. Now as time goes by, you're going to understand what the different radian measures look like, so it's going to be easier and easier. You won't have to convert to degrees when you become familiar with radians. But for now, it's probably best to just convert to degrees so we can determine the value of the ratio. So 60 degrees is a special angle, and I'm going to draw axes just so we can review this stuff real quick. So 60 degrees is about there. And obviously this is a 30, 60, 90 triangle. The opposite side is x root 3. Hypotenuse is 2x. Adjacent side is x. So sine is defined to be the opposite side of the red reference angle divided by the hypotenuse. So we have x root 3 over 2x, and if we cancel out the x's, then we get root 3 over 2. So there you go. So this is really just the same thing that we've been doing in this course. We're just learning what radian units look like for the measure of angles. So let's try another one of these. It's very difficult to find secant 7 pi over 4 because we don't know what 7 pi over 4 is. It's a special angle, but we just don't know what it is. The easiest way to do this is to think about pi over 4 as 45 degrees and just multiply 45 degrees by 7 and you're going to be done. But that may be a little difficult to think about when you first learn radians, so we're going to convert that radian measure to degrees, and 7 times 180 is 1260. And we divide 1260 by 4, we get 315. And the pi's obviously cancel out. So secant 7 pi over 4 is the same thing as secant 315 degrees, and we can see that this is a multiple of 45 degrees. Now that angle is going to be in the fourth quadrant. So let's draw some axes to help us. So we're going to rotate all the way around until we get to the fourth quadrant. And the reference angle is 45 degrees, which means obviously that the sides are going to be x, negative x. Be sure you write negative x, negative x, because that side is below the x-axis. And secant is defined to be the hypotenuse, x root 2, over the side adjacent the green reference angle. So the side adjacent is positive x, and if you reduce, you get root 2, so that's the answer, root 2. So secant 7 pi over 4 is equal to root 2. Secant 7 pi over 4 is equal to secant 315 degrees, which is root 2. So let's try another one of these problems. Now we're going to have a collapsed triangle. So first of all, let's convert pi to degrees. We're going to get 180 pi degrees over pi, and that's just going to be 180 degrees. And we don't need to draw axes because this is a collapsed triangle. Whenever you have an angle that's a multiple of 90 degrees or an angle that is 0 degrees, it's going to be a collapsed triangle. So that means we need to go to our graphs to help us. So we need to find the x value, or find the point on the red curve that has an x value of 180 degrees. Here's 180 degrees right here. And what is the y value on the red curve? Well, it's obviously 0. This point here, that pink point, is 180, 0. So when x is 180, y is 0. So tangent pi is the same thing as tangent 180, which is 0. Okay, so now we have another collapsed triangle because pi over 2 is 90 degrees. We get 180 pi degrees over 2 pi, and we get 180 over 2, 180 degrees over 2, which is 90 degrees. So cosine pi over 2 is the same thing as cosine 90 degrees. And remember, if you have a multiple of 90 degrees, that's a collapsed triangle. So we have to go to our graphs. That's the easiest way to help us find the value. And so here we see 90 degrees. What is the y value that corresponds to that 90 degree x value? Well, it's 0. Again, it's 0. So cosine pi over 2 is 0. Okay, now we have another collapsed triangle, but it's kind of hard to see that, so let's first convert 3 pi over 2 to degree units. So we get 540 pi degrees over 2 pi. The pi's obviously cancel out. And we have 270 degrees. So 3 pi over 2 is the same as 270 degrees. So cosecant 3 pi over 2 is the same thing as cosecant 270. But this is a multiple of 90 degrees, so we have to go to our cosecant curve. You see 270 here, and the corresponding y value is going to be -1. So this point here has an x value of 270 and a y value of -1. So cosecant 270 is -1. So there you go. Okay, we have one more of these problems to do before you try one on your own. This is actually a negative angle measure. So we're going to write -11 pi over 6, and then we're going to convert to degrees. 11 times 180 is 1980 pi degrees over 6 pi, and 1980 divided by 6 is 330. The pi's cancel out. So cotangent -11 pi over 6 is the same thing as cotangent -330 degrees. So in order to figure that out, we're going to draw some axes here. And remember, this is a negative angle measure, so you have to rotate clockwise. -90, -180, -270, and all the way to -330. So the reference angle is going to be 360 minus 330, which is 30 degrees. And obviously this is a 30, 60, 90 triangle, so this side is x, this side is x root 3, and this side is 2x. So cotangent is defined to be the side adjacent the green reference angle. Divided by the side opposite the green reference angle. And as you can see, our trig ratio is going to be root 3. So there you go. Alright, so now it's time for you to try. You can use problems 18 through 23 to help you. So attempt number 24, and when you come back, we'll do it together. Alright, we're back. So pi over 6, if we convert that to degrees, we get 180 pi degrees over 6 pi. is equal to 30 degrees. And so cosine pi over 6 is the same thing as cosine 30 degrees. And that's going to be in the first quadrant. The reference angle is 30 degrees. So we're dealing with a 30, 60, 90 triangle, obviously. The opposite side is x, the adjacent side is x root 3, and the hypotenuse is 2x. And cosine is defined to be the side adjacent the red reference angle divided by the hypotenuse, so we have root 3 over 2. So cosine pi over 6 is root 3 over 2. So if you got that right, good. Okay, I want you to try number 25. 25 is going to be a collapsed triangle, so you're going to need these graphs to help you. So get a picture of these graphs with your phone. Remember, when you have collapsed triangles, angle measures that are multiples of 90, you need to use those graphs. So try number 25, and when you come back, we'll do it together. Okay, we're back. So remember, pi is 180 degrees, but if you want to show that with the conversion, then we get 180 pi degrees over pi, which is equal to 180 degrees. And so we need to find secant 180 degrees, because secant pi is the same thing as secant 180 degrees. So to do that, we have to go to our secant graph and find 180 degrees. So we count out 2, we've got 180, and what is the corresponding point? This is the corresponding point. So the y value is secant 180 degrees, and that is -1. So secant pi is -1. So if you got that right, perfect. Try number 26, and when you come back, we'll do it together. All right, we're back. So 7 pi over 6. If we multiply, we get 1260 pi degrees over 6 pi. And 1260 divided by 6 is 210. So you have 210 degrees. And the pi's just cancel out. So tangent 7 pi over 6 is the same thing as tangent 210 degrees. And to help us with that, let's draw axes. 210 degrees is this angle. Subtract 180 from 210, that gives us our reference angle, which is 30 degrees. The side opposite 30 is -x because it's below the x-axis, and the side adjacent 30 is -x root 3. And the hypotenuse is 2x. So tangent is defined as this side opposite the green reference angle divided by the side adjacent to the green reference angle. So the x's cancel out, and we're left with 1 over root 3. And traditionally, we want to rationalize that denominator. So we multiply both sides by root 3, and we get root 3 over 3. So if you got that right, good job. If you forgot to rationalize the denominator, that's okay. Now you know. So Go ahead and try number 27. 27 is going to be another collapsed triangle, so you really need to use your graphs with these collapsed triangles. Try number 27. When you come back, we'll do it together. Okay, we're back. So remember, 2 pi is the circumference of a circle with radius equal to 1. So we already know that 2 pi is the same thing as 360 degrees. You're going to pick up on these ideas as you get more comfortable with using radians. But for now, let's just do the conversion. We'll show everything. The pi's cancel out. We're left with 360 degrees. So sine 2 pi is the same thing as sine 360 degrees. And if you look at your graph, I'm just going to draw it out rather than have to jump down there. So if you look at your graph, we have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So that's, the y value is 0. So sine 360 degrees is 0. So if you got that right, perfect. Go ahead and try number 28. When you come back, we'll do it together. Okay, we're back. So let's convert 5 pi over 3 to degree units. And we get 900 pi degrees over 3 pi, which is 300 degrees. So cosecant 5 pi over 3 is the same thing as cosecant 300 degrees. So let's look to our axes. We're going to rotate 300 degrees. And if we subtract 300 from 360, we see our reference angle is 60 degrees. The opposite side of 60 degrees is negative x root 3. Negative because it's below the x-axis. And the adjacent side is x. Hypotenuse is 2x. So cosecant 5 pi over 3 is the hypotenuse divided by the side opposite the green reference angle. So we get negative 2 over root 3. But again, it's traditional to rationalize denominators. So I'm going to multiply both sides by root 3. And we get 2 root 3 over 3. And there you go. So if you got that one right, perfect. Okay. Go ahead and try number 29. And when you come back, we'll do it together. Alright, we're back. So we have negative 3 pi over 4. We're going to change that to degree units. And we get negative 540 pi degrees over 4 pi. The pi's obviously cancel out. And 540 divided by 4 is 135. So we get negative 135 degrees. So cotangent negative 3 pi over 4 is the same thing as cotangent negative 135 degrees. And so to help us with this, we're going to draw some axes. And by the way, if you can do this in your head, you don't have to draw the axes. So we're going to rotate in the clockwise direction. Negative 135, that takes us to about there. And subtract 135 from 180, and that gives us the reference angle, 45 degrees. So this side is negative x, this side is negative x, and this side is x root 2. How do I know that? Well, it's a 45, 45, 90 triangle. And cotangent is the side adjacent the 45 degree reference angle. divided by the side opposite the 45-degree reference angle, so that's going to be 1. So if you got that right, perfect. So now we're going to find the values of expressions using a calculator, because these angle measures are not special angle measures. Special angle measures are pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, pi over 6, which is 30 degrees, or multiples of those angle measures. Pi over 2 is 90, pi is 180, and so on and so forth. 2 pi is 360. So as you can see here, we have angle measures that they don't look familiar. So we're going to have to use the calculator. But there's a big problem. Our calculators are not set in Radian mode. So if you have a TI-84 Plus Texas Instruments calculator, I'm going to show you how to do that right now. And I'll also show you how to do it on an iPhone. If you have a different calculator, you can go online and just research how to do that. So with the TI-84 Plus, and with any Texas Instruments calculator, it's going to be roughly the same. So what you're going to do is you're going to push the mode button at the upper left. The mode button right next to the blue second button. The mode button, push that. Then you're going to use the arrows at the right to go down, and it's going to have degree highlighted. You want to go down where it says radian and push enter, so radians are highlighted. Then I want you to push the blue second button at the upper left, blue second button, and then you're going to push the mode button again, because that quits out of that. So now you're in radian units. If you're using an iPhone, I want you to rotate your phone so it's in landscape mode, and at the bottom left, most likely you're going to see a button that says rad, R-A-D, rad. At the bottom left, the button should say rad, or it might say DEG. If the button says rad, then that means that you're in degrees. If the button says DEG, that means you're in radian units. That's very confusing because it's the exact opposite of what you would think. So you want to push that button where it says rad, and it should change to DEG. You want the button to say DEG. Now you're in radian units for the measure of angles. Again, that's just how the programmers designed that calculator. It's very confusing. At the upper left, you'll see a rad abbreviation appearing and disappearing. So when you see that rad abbreviation there, that means you're in radians. Again, it's very confusing the way they program these calculators. So again, you can push that button. It'll change back and forth between rad degrees, rad degrees. You want the bottom left button to say DEG. That means you're in radians. So now let's use the graphing calculators to find sine pi over 9. Push the sine button, and then you're going to push the blue second button at the upper left, where that blue button, and then you're going to push the upside down V button that's below the clear button, where it says clear. You see that blue pi there? It's the upside down V button. You're going to push that, and then you're going to push divided by 9, and then enter. You don't have to have an end parenthesis. And we get 0.342, and we're rounding to the nearest thousandth, so we can just leave the answer like that. 0.342. So there you go. Okay, so if you're using an iPhone, it's going to be completely different. You have to press the pi button, then divided by 9 equals, and then you're going to push the sine button. So again, the pi button in the middle, divided by 9 equals, and then you're going to push the sine button. Okay, so let's try 31. In the graphing calculator, enter cosine, and then 5, and then the blue second button, and then the pi button at the right, divided by 7, enter, and you should get approximately negative 0.623. Again, if you're using an iPhone, you want to enter, you want to press 5 and then times the pi button and then equals, and then divided by 7 and then equals, and then you're going to push the cosine button, so it's all backwards. I know that's confusing, but that's just what you have to deal with. Okay, so let's try 32. Press the tangent button and 3.4 and then enter, and there you go. So again, 3.4 is in radian measure. How do I know that? Because there's no degree symbol. So we get 0.264. So there you go. Okay, if you're using a graphing or an iPhone, again, you want to enter this first and use the exact pi button. We don't want round off error. A lot of students would say, well, I want to use 3.14 for pi. Well, why do that when you can just use the pi button in your calculator? So again, if you're using an iPhone, you want to enter 3.4 first, then push the tangent button. So try number 33. When you come back, we'll do it together. All right, we're back. So in my graphing calculator, I'm going to push the sine button, and then 2, and then pi, and then divided by 5. And we should get approximately 0.951. So if you got that right, excellent. Try number 34. When you come back, we'll do it together. All right, we're back. So tangent 6 pi divided by 13 is approximately 8.236. So again, if you're using an iPhone, you want to enter this first and make sure you use the pi button, and then once you get this number, then you want to push the tan button, or it looks like a tan button, but it's really the tangent button. Try number 35. Again, there's no unit here, there's no degree symbol, so that means we're in radians, even though we don't see a pi. Try number 35. When you come back, we'll do it together. Okay, we're back. So in my graphing calculator, I'm going to enter or press the cosine button, and then enter 7, and then press the enter button, and I get 0.754. So if you got that right, good. If you're going to use an iPhone, press 7 and then press the cosine button, and then you have your answer. Okay, so now we're going to solve equations as we did in previous classes, but we're going to write our answer in radian units. Now, why are we going to do that? Well, because it says up here, theta is between 0 and 2 pi. And there's no degree symbols anywhere here. So that means that we're in the radian unit. They want us to find the answer using radian units. And sometimes the problem will actually tell you that, find your answer in radians, but really this is the clue here. We know that they want the answer in radian units. So I am going to subtract cosine theta from both sides of the equation. And then I'm going to divide both sides by -2. And you may recognize this ratio as x over 2x. So that's a 30, 60, 90 degree triangle. So let's draw some axes to help us. Cosine is positive in the first quadrant, but it's also positive in the fourth quadrant. And the hypotenuse is 2x, and cosine is adjacent over hypotenuse, so the adjacent side is going to be x, and the opposite side is x root 3, of course. Over here it's going to be negative x root 3. And so we have to ask the simple question, what are the reference angles? Well, remember, the side that's opposite the 60-degree angle is x root 3, so that angle must be 60. And of course this angle is also 60. The reference angles are always the same. In the first quadrant, the reference angle is the actual angle if your angle measures less than 360. But over here, the actual angle measure is this red measure here, which is 300 degrees. So we want the angle measures between 0 and 2 pi, which means between 0 and 360 degrees. So these are the answers, but the problem is we're supposed to write our answers in radian units. The problem implies that we need to do that. So theta is equal to 60 degrees and 300 degrees, but we're going to take 60 degrees and convert to radians. So I'm going to multiply by pi over 180. The pi is going to be on top when we're converting to radians. So the degree symbols cancel out, and we have 60 pi over 180, which reduces to pi over 3. So that is one of the answers. But we also found that 300 degrees is a solution between 0 and 360. So we're going to convert that to radians. The degree symbols cancel out, and we're left with 300 pi over 180. And if you reduce that, you get 5 pi over 3. So the final answers are pi over 3 radians and 5 pi over 3 radians. Those are the solutions between 0 and 2 pi. So these are the same problems that we did in previous parts of the course. The only difference is we're just writing our answers in radian units for the measures of the angles. So let's try number 37. We'll do a couple more of these before you try one on your own. So we're going to add those tangents. We have 1 tangent plus 7 tangents is 8 tangents. 8 tangent thetas. Now we're going to divide both sides by 8, and we get tangent theta is equal to 1. So now we need to draw our axes. You may recognize that ratio as x over x, so that's a 45, 45, 90 triangle. And tangent is positive in the first quadrant and the third quadrant. And the reference angle in both these cases obviously is 45. The reference angles are always the same. So one solution is 45 degrees and another solution is 225 degrees. So we found that by adding 45 to 180. The opposite side over here is negative x, this side is negative x, this side is x, this side is x. And that's how we know when we divide the opposite side, because tangent is defined as the opposite over the adjacent side. If we divide two positives, we get a positive, but if we divide two negatives, we get a negative also. That's how we know it's in the third quadrant. Again, this is all stuff that we went over in previous classes. So, we have our solutions. theta is equal to 45 degrees and 225 degrees, but again we want our solutions in radians, so I'm going to take 45 degrees and multiply by pi over 180. The degree symbols cancel out, and we have 45 pi over 180, which is equal to pi over 4. Now I'm going to convert 225 degrees to radian units. Again, the degree symbols cancel out, and we're left with 225 pi over 180, which is equal to 5 pi over 4. So our final solutions are pi over 4 and 5 pi over 4. Those are the solutions between 0 and 2 pi, because again it says up here, find theta if theta is between 0 and 2 pi. So again, this is all just review. We did this in previous classes. We're just solving trigonometric equations, but now we're writing our solutions in radian units. Okay, let's try one more of these before you try one on your own. I'm going to add 2 cosecant theta to both sides. And then I'm going to add 3 to both sides. And I'm going to divide both sides by 7. And this is actually a collapsed triangle. So we need to look at the cosecant curve and ask ourselves, what point on the cosecant curve has a y value of 1? What point on the cosecant curve has a y value of 1? And the answer is this point here. And that corresponds to 90 degrees. So 90 degrees is the angle that we're looking for. And that's really the only solution between 0 and 360. But we don't want the solution in degree units. So we're going to convert 90 degrees to radian measure. Again, the degree symbols cancel out, and we're left with pi, actually 90 times pi over 180, which reduces to pi over 2. So theta is equal to pi over 2. That's the solution between 0 and 360, or 0 and 2 pi. Remember, 2 pi is a complete rotation. Okay, so now it's time for you to try. You can use problems 36 through 38 to help you. You want to get all those signs on one side and all the other numbers on the other side, and you may need to use these graphs if you have a collapsed triangle. If sine is equal to 1, 0, or -1, then you're going to have a collapsed triangle, so be aware of that. Try number 39, and when you come back, we'll do it together. Okay, we're back. I'm going to subtract sine theta from both sides. And I'm going to subtract 4 from both sides, and it looks like we do have a collapsed triangle. So sine theta is equal to -1. So we look for the point on the red curve that has a y value of -1, and we see that's here. So that corresponds to 270 degrees. So theta is equal to 270 degrees. But we need to write our solution in radian units. So 270 times pi over 180 degrees. The degree symbols cancel out, and we're left with 270 pi over 180, and that is equal to 3 pi over 2. So theta is 3 pi over 2. So we got that right. Perfect. If you had a little trouble with that, that's okay. Again, that was a collapsed triangle. Okay, go ahead and try number 40. And when you come back, we'll do it together. Alright, we're back. So I'm going to add 2 cotangent theta to both sides. I guess I'll do this in steps. And then I'm going to divide both sides by 3. And you may recognize this as negative x root 3 over x. We don't really know where the negative goes, we just know the negative is there. So that's a special triangle. Cotangent theta is negative in the second quadrants, or second quadrant and the fourth quadrant. And we know that because well, first of all, cotangent is the adjacent side over the hypotenuse. So the adjacent side of the green reference angles must be x root 3. In this case, it's negative x root 3. And in this case, it's just x root 3. Which means that this side is x and this side is negative x. So we know that cotangent is negative in the second and the fourth quadrants because the signs are different on the legs of the triangles. So when you divide, you get a negative number. And of course, the hypotenuse on each of these triangles is 2x. So now we need to find the actual angles. Now, what are the reference angles? Well, the side opposite the green reference angle is x. So that means that the reference angles must be 30 degrees. Subtract 30 from 180 and you get 150. So the first angle is actually 150 degrees. Subtract 30 from 360 and you get 330 degrees. So that's actually the second angle. So theta must be equal to 150 degrees and 330 degrees. Again, there's an infinite number of solutions, but we're only looking for the solutions between 0 and 360. So now we're going to convert 150 to radians because they want the answer in radians. So we have 150 pi over 180, which is 5 pi over 6. And we're going to convert 330 degrees to radians. Again, the degree symbols cancel out. And we're left with 330 pi over 180, which is 11 pi over 6 radians. So the final solutions are going to be 5 pi over 6 and 11 pi over 6 in radian measure. So if you got that right, perfect. Okay, now let's try number 41. Go and attempt 41, and when you come back, we'll do it together. Alright, we're back, so I'm going to add the secants to get 6 secant theta is equal to negative 6 root 2. And I'm going to divide both sides of the equation by 6 to get negative root 2. And you may recognize this as negative x root 2 over x. That means it's a 45, 45, 90 triangle. So let's draw our triangles. Secant is the adjacent side, actually the hypotenuse over the adjacent side. So that means that our triangles must be in the second or third quadrant because the hypotenuse is always positive, so the adjacent side must be negative. So we have one triangle in the second quadrant, and we have another triangle in the third quadrant. So here's one angle, here's the other angle, and the hypotenuse is going to be x root 2. The hypotenuse is always positive. The adjacent side has to be negative x. We know it has to be negative x because our ratio is negative. So the reference angle is going to be 45 degrees, obviously. This is obviously a 45 degree reference angle for both these triangles. And now we just do basic math. 180 minus 45 is 135 degrees. That's the actual angle we're looking for. And then 180 plus 45 degrees is 225 degrees. That's the actual angle we're looking for between 0 and 360. So theta is equal to 135 degrees or 225 degrees. But we need to show our answer in radians. So I'm going to convert 135 degrees to radians. The degree symbols obviously cancel out. And we're left with 135 pi over 180. And that reduces to 3 pi over 4. So now we're going to convert 225 degrees to radians. And we get 225 pi over 180. And so that's going to be 5 pi over 4. So the final solutions are 3 pi over 4 and 5 pi over 4. So if you got that right, perfect. So that was the class today. If you'd like to take screenshots of all the work that we did today to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3 and number 4 and number 5 and number 6 and number 7. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1 of the homework. And screenshot number 2. And you have the answers at the bottom right. So be sure to get that homework done completely and correctly. Remember, if you don't do the homework, you're not going to learn what you need to gain fluency and proficiency with this material. So get that homework done, and I'll look forward to seeing you in the next class.